Welcome everyone, I'm Brian Walsh, and in this lesson we're going over how to calculate percent yield.
When you calculate percent yield, you're going to use this equation. So you're going to take the actual yield divided by the theoretical yield times 100. So let's take a look at what the theoretical yield actually is. The theoretical yield is the calculated yield from your stoichiometry problems. So when you convert grams of reactants to grams of products, these grams of products that you find is your theoretical yield. The other part of the equation is the actual yield. The actual yield is the amount of product that actually forms. So this is a measured value. This is not something that you calculate. In other words, the actual yield is what you get when you mix the reactants together, let the reaction take place, and then weigh however much product you get. If you're having trouble remembering the difference between the actual yield and the theoretical yield, just remember that the actual yield is always less than the theoretical yield, because the theoretical yield tells you the maximum amount of product that can form. Now let's do a sample problem that has us calculating percent yield. So this problem says when 100 grams of silicon dioxide, which is sand, reacts with excess carbon, 51.4 grams of silicon carbide is recovered. What is the percent yield of silicon carbide from this reaction? Since we're trying to calculate percent yield, that means we're going to need to find the actual yield and the theoretical yield. So the problem tells us that 51.4 grams of silicon carbide is recovered. And this is recovered. This tells us that this 51.4 grams of silicon carbide, this is the actual yield. So since we have the actual yield, all we have to find now is the theoretical yield. And remember that theoretical yield is a calculated value, which means that we're going to have to convert 100 grams of silicon dioxide to grams of silicon carbide. So if we remember our diagram, that means we're going to be going from grams of silicon dioxide to grams of silicon carbide, which means that our first step is going to be to convert grams of silicon dioxide to moles of silicon dioxide, and we do that by using the molar mass of silicon dioxide. And if we use our periodic table, we calculate the molar mass of silicon dioxide at 60.09 grams per mole, and this is rounded to 4 significant figures. So we start our calculation with 100 grams of silicon dioxide, and then we're going to convert this to moles of silicon dioxide using the molar mass. Like always, we set up our conversion factor so that our units cancel, which means we're going to have grams of silicon dioxide on the bottom to cancel with grams of silicon dioxide on the top. So these grams cancel with these grams, and now we have moles of silicon dioxide. So now we have moles of silicon dioxide, which means we're here on our diagram, and we can see that our next step is going to be to use the balanced equation to go from moles of silicon dioxide to moles of silicon carbide. So if we look at our balanced equation, we see that we have 1 mole of silicon dioxide per 1 mole of silicon carbide. And we set up our conversion factor so that our units cancel, which means we have moles of silicon dioxide on the bottom to cancel with moles of silicon dioxide on top. So these moles cancel with these moles, and now we have moles of silicon carbide. So now we have moles of silicon carbide, which means we're right here in our diagram, which means we just have one more step, which is to convert from moles of silicon carbide to grams of silicon carbide. And we do that by using the molar mass of silicon carbide. Using our periodic table, we calculate the molar mass of silicon carbide to be 40.10 grams per mole. We set it up so our units cancel, which means moles of silicon carbide on the bottom to cancel with moles of silicon carbide on top. So these cancel with these, and now we have grams of silicon carbide. And because this is what we're trying to find, we can go ahead and do our calculation. So we multiply 100 times 1 times 1 times 40.10 and divide by 60.09. And what we get is 66.7 grams of silicon dioxide. So this is our theoretical yield. Now that we know our actual yield and our theoretical yield, we can go ahead and calculate our percent yield. So we do actual yield divided by theoretical yield times 100. And what we get is a percent yield of 77.1%.
If you have any questions about anything, or if you have any feedback that you'd like to give me, please leave me a message. You can leave a comment, or you can email me at chemistrymadeeasy118@gmail.com. Thanks for watching.